Alright guys, so this is 7.4. We're going to look at log functions. So let's remember last section we were doing e's and exponentials, right? So we have our in the x function. And if you talk about the inverse, which is the reflection over y equals x, right? We get this graph right here, which is our ln of x. So e and natural log are inverses of each other. Remember what inverse means. It means that they pretty much cancel each other out, right? Like addition and subtraction, multiplication, division, so on and so forth. So 7.4 here should just be kind of a review of logarithms and natural log. So here in this chart it talks about different parts of the graph we want to remember. So the base is greater than 1. Our domain, right, is from 0 to infinity of our ln or our logs. Our range goes from negative infinity to infinity because it keeps continuing. And as you can see, there's a vertical asymptote at the y-axis, so x equals 0. Okay. Now, the other thing we would need to keep in mind, because remember that e to the x has a y-intercept at 0, 1, that when we do the inverse, so for ln, that means when x is 1, y is 0. And this is always something you want to remember. Okay? So, first it wants you to graph in your graphing calculator our ln and our e. So, or our log, let's say. So, in your graphing calculator, let me clear this out. So, let's first do ln of x. Okay, and we're going to graph that. Okay, so I'm going to graph ln in green. So it comes down because we have an asymptote and it eventually goes this way. Okay. Now we're going to do our basic log. So we'll go back to y equals. We get log, and then by the way, log is down here. Log of x. Don't forget that when we do log in our calculator right here, it's log base 10. So even though we don't see a base, we see base 10. Okay, so let's graph that. So remember the original was ln, and our log base 10 is on the bottom here, but we are still going through, and I'll prove it to you, we are still going through 0, 1. Okay, so again, asymptote down here, but it's going to be lower than our ln. Alright, so let's talk about transformations of our ln. Okay, so without a calculator, let's remember what subtracting 2 on the inside means. Subtracting 2 means we're going to go over to the right 2. And the absolute value on the outside tells you you're going to flip everything up. So no negative y's. Okay, so what does that mean? Well, let's remember we had an asymptote at 0. So now if we move that over 2, we have an asymptote at 2. Our x-intercept here was at 1, but since we're moving over 2, it's going to be at 3. Okay? Now, usually we would graph close to our asymptote, right? But since we are doing absolute value, it flips it up. So we're actually going to come down here. Okay? And then the rest of it is still the same. So there we go. It says write an equation for the graph's asymptote. So we have it at x equals 2. Alright, so we can still do transformations with ln's and logs. Just remember what the original graph looks like. Alright, so now we're going to talk about changing forms and just doing some stuff from last year. So here we go. We can change an e to an ln. The exponent is what is on the outside now, and we do ln of x. Same thing with our exponential here. Our exponent comes on the outside, our log of base of x. Okay, switching back and forth. So we're going to make this exponential into a log. First thing I'm going to do is write log. If our base is 3 up here, our base is 3 in the log. But now we say that we get log base 3 of 81 equals our exponent of 4. Same thing down here. We're going to change our e to our ln. So we have ln of 1 equals our exponent 0, which we did that on our graph, right guys? Here we're going to change it backwards. Now remember that if you do not see a base there, it is automatically base 10. So in our exponential, we're going to start out with 10 as our base. Now let's remember which one is our exponent. Our exponent is on the outside here. So 10 to the negative 1 equals 0.1. Alright. So as we saw in B, we always have to remember that ln of 1 is 0. We can't have any ln's of negatives or ln of 0. Remember, there's an asymptote there, so it does not work. Same thing that e to the first is just e. So when we have ln of e, right, they cancel, leaving us just 1 because that exponent there is 1. Alright, so these are a couple of things to keep in mind. ln and e cancel, leaving us n. Same thing on this side. E and ln cancel. So the answer is just that exponent. This is a good way to get our exponent down to a level that we can solve, and eventually we're going to do that. So ln and e cancel, we get square root of 2. E and ln cancel, we get 3x. Log base 10 right there, right? Because there's nothing there. That cancels with base of 10, so we're left with 2. And again, log base 2 and base 2 cancel, we're left with x squared. Alright, some of these log properties should look familiar since you should have done logs last year, or ln's, so keep in mind that this is log and ln's. When you see multiplication, we can expand it into 2 logs by doing a plus b there. Division is subtraction, and power to power means we can move that exponent out front. Okay, this will allow us to put it in different forms so we can take integrals and derivatives way easier. So in 7.4 here, they're going to have you practice doing a bunch. So we're going to expand right now. So this is division, which means we need to do what? Subtract. So our answer should be ln 5 minus ln 8. And don't forget, guys, that these are actual constants. These are numbers. Okay. This one looks a little bit trickier, right? Because we have a lot going on here. So let's make this look a little bit clearer by doing x squared plus 1 to the 1/3. What did we do with that exponent? Well, we put it out front. So we get 1/3 ln x squared plus 1. Now let's check. If we were to expand this, do we have any rules for 1 log or 1 ln with addition? No, we don't. See, it has to be 2. Sorry guys, the lights went out, so let's just continue. Condense into a single logarithm. So we're going to make this into 1 ln. The first thing we are going to have to do is put our exponents back. So we get ln x to the negative third plus ln y to the fifth. We have 2 ln's. We're going to condense this into 1 ln. And then with addition, what do? We multiply. So we would have x to the negative 3 times y to the fifth. You could keep that in this form, or as we know, negative exponents turn positive if we put it in the other area. So let's put that x cubed into the denominator. So either one of these is correct. Alright, B. Let's first do our exponents. So we have ln x to the 1/2. Well, what is x to the 1/2? It is the square root. Either you can keep it as the square root or keep it as x to 1/2. Either way is fine with me. Okay, we're not switching anything there, so it's still x plus 1 minus ln y to the third. Now, some of your teachers last year might have made you do this separately. I tried to show my students the quickest way. So if it's addition, remember it's multiplication. If it's subtraction, it's division. So if it's a positive in front, so these two terms are positive, it is automatically going to go into the numerator. So I have x and 1/2 times x plus 1. And because that last term is minus, we're going to put that in the denominator. Remember not to take the ln with it, because we are condensing into 1 ln. Okay, a couple more left. Now let's do some solving. Don't forget, to get rid of something, you do the inverse. So we are going to try to get x by itself. Okay, the first thing we are going to want to do here, there we go. First thing we need to move over is that 6. So we're going to go y minus 6 equals e to the 2x minus 5. Now our issue is still that our x is in the exponent. So we need to bring that down to be able to move with it. We have to get rid of that e. How do you get rid of e's, guys? You do the ln. And whatever you do to one side, you need to do to the other. So see how they're going to cancel out? So right now I'm left with ln. And let's put parentheses around the y minus 6. So we know that that minus 6 is in the ln. And we have equals 2x minus 5. Okay, what's our goal still? Is to get x by itself. So our next thing would be to add 5 to both sides. Now you can either put it in front or in the back, doesn't matter. Equals 2x. And then how do you get x by itself? Divide by 2. So our answer is x equals ln of y minus 6 plus 5 all over 2. Okay. B. I've seen a lot of mistakes with this because people think that they can just take the base 2 to get rid of these two logs. But you can't take the base 2 of two different terms. What we're going to have to do is condense it into one term first. So keep in mind, we cannot get rid of log base 2 until we only see one log base 2. Okay? This is subtraction, so what do we do to condense it? We divide. So I have log base 2, and it's going to be x over x minus 8 equals 3. So how do we get rid of log base 2 is we just use the base of 2. But whatever we do to one side, we have to do to the other. Those cancel, leaving on the left side we have x divided by x minus 8 equals, and we can actually do this out. 2 to the third is 8. Alright, now we're going to do some algebra here. So let's go, we're going to multiply both sides by x minus 8. We want to distribute that 8 out, so we get x equals 8x minus 64. Okay, I'm going to bring this right up here, guys, so I have some room. I'm going to subtract 8x from both sides, so I get negative 7x equals negative 64. And then I have x equals 64 over 7. Now, of course, this is solving, so we could plug this back in and check it out. But what I want to mention first is when we do 64 over 7, does that make this log a negative? No, it does not, because we can't take a log of a negative. So far, so good. Now, let's check it in here. If we did 64 over 7, oops, sorry, it's a little dark, don't forget the lights are off here. 64 divided by 7, and we subtract 8, we still get a positive number, so this answer is good. If it turned out to be negative, we cannot take a negative, we cannot do a log of a negative number, so then we would cross it out. Alright, so this area down here, guys, has this change base form. So what I'm going to do here, though, is you can go and follow this and say log base a of x. The idea is last year your teacher said, hey, the only log on your calculator is log base 10. Do you remember that? So if we had example log 7 112, to do that on your calculator, you actually had to change this to log 112 all over log 7. Does everyone remember that? Okay, you can do it that way, or something new with our calculators. If you go to math, right, our magical button that helps us with everything, and you keep going down, you go to A, it says log base. So if I press enter, what do you know? I can actually calculate that without doing the division. So I'm going to show you they both equal the same. So 7 is our base, and we're doing 112, right? So log base 7 of 112 is 2.425. I can show you also that when we did before, log 112 divided by log 7 equals same thing, okay? But magical, we actually can do different bases in our calculator as long as you have a TI-84, right? We have to know how to use our tools. All right, you can start 7-4 or move on to 7-5.